Welcome to our tutorial on significant figures. Today's essential question is how should measurements be reported to others to accurately show the precision and accuracy of the measurement. So significant figures, and what I'll call Sig Figs, are the number of digits thought to be correct by the person doing the measuring. This includes all digits when we're measuring that can be read directly from the device plus one estimated digit. So here in this beaker we have 40 milliliters here, 50, 60, but I'm somewhere in between 40 and 50, and so I could estimate to the nearest one. So I'd probably estimate about 44 milliliters here. Over on this graduated cylinder, I have 35, 36, 37, 38, 39, 40. My meniscus is at the bottom here, and it's somewhere in between 36 and 37. So I would probably round to 36.5 milliliters here. So we can estimate to one digit past what the device actually measures. When we're counting sig figs, and I'll get rid of my picture for a moment up here, non-zero digits are always significant. So in 34.57, all four of these digits are significant. Our second rule is that leading zeros are never significant. So in 0.0061, these three zeros are just placeholders. We only have two sig figs here. So in the first one we had 4 sig figs, the second one we have 2. Our third rule, zeros within a number between non-zero digits are always significant. So because this is a non-zero digit and this is a non-zero digit, this zero is significant. So we have a total of 4 significant figures. Our next rule, zeros that show only where the decimal point is going to fall are not significant. So in other words, zeros that are placeholders. So if we look at 470,000, these 4 zeros right here are only holding the place so that we know where the decimal lies. And so we have 2 sig figs. Trailing zeros that aren't needed to show where the decimal point falls are significant. So in 4.00, yes, these are trailing zeros, but they're not showing me where the decimal lies. They're actually showing me a certain amount of accuracy and precision. So this number has 3 sig figs. Finally, we have some numbers that have an infinite number of sig figs, and these are truths. And so truths will not play into significant figures at all. When we round sig figs, we're going to just use the old adage that if it's less than 5, then we're going to round down or keep it the same. If the number behind what we're rounding to is greater than 5, then we're going to round up. So in our two examples here, 2.344, if we're rounding to 3 significant figures, so here's 1, 2, 3 significant figures, I'm rounding to this number. I look one behind it, and because 4 is less than 5, my answer would be 2.34. In my second example here, I'm rounding to 3 sig figs, so here's 1, 2, 3. I'm rounding to this number here. I've got to look behind, and because 8 is greater than 5, I'm going to round up, or give it a shove, as some people say, and we would have 2.35 as our answer. Alright, so let's talk about sig figs when we're doing multiplication and division. The least number of sig figs in any number of the problem determines the number of significant figures in the answer. So the first thing I'm going to do is I'm just going to go ahead and calculate this answer. So if I put 2.5 times 3.42 in my calculator, we get 8.55. So now I'm going to look at the sig figs in my problem. Here I have 2 sig figs. Here I've got 3 sig figs. I want the least number, so I'm going to have 2 sig figs in my answer, so this actually becomes 8.6 when I round. Because I'm rounding to this, I have to round up because I have the 5. In my next one, 4.52 times 10 to the negative 4 divided by 3.980 times 10 to the negative 6. Again, I'm going to plug that into my calculator. And if you plug it into your calculator, you get 113.567839196. Well, I need to look at my sig figs. My sig figs, remember that these zeros and these zeros are only going to be placeholders. So here are my number of sig figs right here. So I have 3 and 4.52. I've got 4 and 3.980. I'm going to take the least number of sig figs, which is 3. So I'm going to round my answer to the nearest 1. And because I have 5, I'm going to give it a shove to 114. And that would be the answer that I report. When I do addition and subtraction, it's a little bit different. We're going to count the number of significant figures in the decimal portion of each number in the problem. We're going to add or subtract in normal fashion. And then we're going to answer the least number of places in the decimal portion. And that's different than what we had previously in multiplication and division. We're going to look at the decimal portion only of any number in the problem. So if I add this in my calculator, I've got 3.46, so on and so forth. We add these all together, I'm going to get 23.3395829113. So now I got to look at the number of sig figs in my decimal portion. Well, I've got 1, 2, 3, 4, 5, 6 here. 7 total, but 6 in my decimal portion. Here I have 2. Here I have 1, 2, 3, 4, 5, 6 again. And in 5.2631, I've got 4 in my decimal portion. The least number in my decimal portion would be 2. So I'm going to have 2 decimals, so this would actually equal 23.34. Alright, that's the end of today's tutorial. Hope everyone gets all the questions right, and I'll see you tomorrow.